Well, this worksheet is really defining two different things that are similar, and that's where we run into trouble sometime when things are similar and we can't tell them apart. A permutation and a combination sound sort of the same, but they are different. When do we use permutations? We use permutations when order matters. When order matters, that means like if you're looking at setting a lineup for a baseball team, what order they're going to bat. If you're a bowling order, if you have a bowling team of 4 players and you're selecting from 6 or so, you want to, how many different ways can you have a first, second, third, and fourth? What to do? Well, there's a notation for that. NPR it's a permutation of n items taken r at a time. Okay, and there's a specific thing that you'll do. You take the n value, which is the number of folks you're selecting from, factorial, and you divide that by n minus r factorial, which means you're finding the difference. So in the case where I had the bowling order, where you had 6 players, and you wanted to create a lineup of 4 specific bowlers in a specific order, you would simply take the 6 factorial on top, you would put that over 6 minus 4 factorial on the bottom. I didn't leave myself too much room, but that's up here, that's 6 factorial over 2 factorial, which doesn't help too much. 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. You're going to cancel those guys, and you end up with about 720 different ways, different bowling lineups that you can have. Now, a combination, that might look similar to what we do over here with a combination. If I did a similar situation, well, if I said I wanted to just say, well, how many people can I actually take to nationals, and I only can get the 4 tickets, we can't take all 6 players. So we had the same bowling situation where we had 6 bowlers on a team, but only 4 could play in the game. And we want to see how many different lineups, first, second, third, and fourth, we can have. If we apply that same thing to this situation over here and just say, how many ways can we take a group of 4 people with us, not necessarily establishing an order, just to see how many people can come, well, that's when we would use a combination. You use that when order doesn't matter. Doesn't matter, okay? And that means we're just looking for a team. Words like team or group, and that type of thing is what you want to kind of include here. So the notation is the same, except with a C for a combination, NCR, and the equation is similar, and it is the same n minus r factorial, but there's also an r factorial to account for all the different ways that people can be arranged if they're on the same team. So with the same situation here, if we do the 6C4, so a much smaller number of people, or a much smaller number of arrangements that could be made. So 6 minus 4 here, factorial, and then the 4 factorial. And we'll do that just down here in the space that we have below. It's 6, let me do it this way, factorial over 2 factorial and 4 factorial. So when we simplify that, your 6 is only going to have to go down to 4 because we have a 4 factorial on the bottom. Keep in mind, that's a 4, 3, 2, 1, that's a 4, 3, 2, 1. But we still have this 2 factorial. Well, if I multiply 2 times 1, it's basically just a 2. So you got to keep track of the fact that this is a factorial that needs to be extended if it can be. We'll show you some other examples. The 4 is canceled, the 2 goes into 6. 3 times 5 is equal to 15. So there's only 15 different ways you can create teams of 4 people out of the 6 that are available here.